In this video, we're going to start, or this video series, excuse me, we're going to look at logarithmic functions, okay? And logarithmic functions are going to be the inverse of exponential functions. So, objectives of this series is we are going to convert between logarithmic and exponential forms of equations. We're going to evaluate logarithmic expressions analytically, okay? That is, we're not going to use a calculator or a graph. We're going to define the natural logarithmic function. We're going to graph log functions and give domains of range and asymptotes, just like we did for exponential functions. We're going to graph log functions using rules of transformation, just like we did for exponential. And then finally, we're going to find domain of a logarithmic function analytically. All right, so basically, if I give you a log function, not using the graph or not using any sort of device, we're going to find the domain of that function. So let's set some basic rules for logarithms. So a logarithmic statement is the inverse of an exponential statement. And the inverse of an exponential function with base b is called logarithmic function with base b. So this is what we're going to be looking at throughout this video series. All right, so f of x equals log base b of x. Now, the base b has to be greater than 0. All right, so we can never have a negative base. B should not be equal to 1, and we'll see why that is in a little bit. And then whatever's inside of that function, the independent variable x, that should be greater than 0. Right. If we see a log with no base, so if we see this, f of x equals log x, there's really a base of 10 there. Okay, so that's called the common logarithm. All right, so log of x is really the same thing as log 10 of x, right? And what we can do is with a common logarithm, we can just rewrite this such that f of x equals 10 to the x. All right, so that's going to be the base, right? The natural logarithmic function has a base of e. So if you ever see ln of x, okay, that's the same thing as log base e of x, okay? And the functions ln x and e to the x are inverses of one another. And we've explored e to the x in detail, right? So essentially, the way that we convert back and forth between logarithmic and exponential equations is if we see this, log base b of x is equal to, or excuse me, let's say log base b of x is equal to y. What that means is that x is equal to b to the y power. Okay, so these two statements mean the exact same thing. And this is going to be really important to us throughout this entire video series. Okay, so if there's anything that we really want to hold on to and memorize, all right, of course it's everything, but this is of particular importance. Okay, one of the things that I learned way back in 1813 when I started taking mathematics was that just remember that the phrase logarithm is an exponent. Okay, so a logarithm is an exponent. So this is going to be our exponent, and this is our base. Okay, so if you look at it, okay, this x is going to be the base raised to whatever y is. Okay, so that might be the easiest or an easy way to think about it. That's what I always remember is that a logarithm is an exponent to kind of help me to translate back and forth between logarithmic and exponential form. Okay, now that I know that, what I can do is I can start working some exercises to where all we're going to do is we're just going to convert each of these equations into its exponential form, right? So we have 2 equals log base 7 of 49. Okay, so logarithm is an exponent, so 2 is the exponent, and then 7 is the base, right? And so what we could do is we could rewrite this as base is 7, exponent is 2, and then the 49 just stays where it is, right? And of course, that's a true statement, okay? So every time we perform these sorts of conversions, then we should get a true statement out of it. 5 equals log x of 32, okay? So our base is x, okay? So that's our b. 5 is our y, which is going to be our exponent. And so this just translates into base x and then exponent 5. The 32 stays where it is, since 32 in our formula is x. Okay, so this is it. That's all we're asking you to do to convert back and forth between exponential and logarithmic form. Okay. All right, so in our next video, what we're going to do is we're going to go the other way to where we convert into logarithmic form, all right? And then what we can do is we can try to start evaluating some of these logarithmic expressions.